we go on to the next one. Okay, we're going to talk about elements, compounds, and mixtures. So, something that's an element is made of all one type of atom. So these are atoms of an element. Sometimes elements like to hang out as molecules. A molecule is two atoms or more that are stuck together. So this would be molecules, still of an element though. Notice that they're the same color stuck together, meaning they're the same element. Then, over here we have molecules of a compound. These compounds have different elements that make the compound, so you can see like there's three of one color and one atom of another color. Then over here we have a mixture, which is a mixture of elements and a compound. So you see all different colors. When it's a mixture, they're not connected together, so they aren't taking on those different properties of the compound. They still keep their same properties as they did separately, only they're mixed together, kind of like salt water. Salt tastes salty, whether it's regular salt or whether it's in water, it still tastes salty. Okay, feel free to hit pause before we go on. So, we're going to review a little bit of those definitions. So an element is made up of just one kind of atom, cannot be broken down by physical or chemical changes. Now, if you think you have this pretty well, just go ahead and fast forward through this section. You don't have to write this one down. The smallest part is an atom, and some examples are Cu. Remember what element that is? What about O? How about S? Those are all chemical symbols that represent different elements. And basically anything that's found on the periodic table is an element. Okay, we have a joke break for you next. What is a pirate's favorite element? I know. Argon! That's a good one, isn't it? Okay, whatever. Let's move on. If something's a compound, it's two or more elements chemically combined, and they can only be separated by a chemical change. Feel free to skip ahead on this one if you think you have it already. Otherwise, you don't need to write it down unless you feel you have to. The smallest part of a compound is a molecule, and some examples would be CO2, carbon dioxide, or H2O, water. And those are examples of chemical formulas. The CO2, the little 2, means that there's one carbon atom for every 2 oxygen atoms in each molecule. For H2O, the little 2 after the H means there's 2 hydrogen atoms and 1 oxygen atom. Then the next definition we have is a mixture. The definition of a mixture is 2 or more materials in the same place that can be separated by physical changes. They're made of elements and compounds, and some examples might be Kool-Aid, cookie dough, or cement. So if you have any questions on those, you can feel free to rewind, write those things down, pause, otherwise we're going to keep moving forward. In order to make a mixture, you have to go through the process of dissolving. So in this process, water molecules will start to surround each particle of salt and separate them from the rest until they're all evenly distributed. So if you see in this picture, this could be salt or sugar or anything that you put into a cup of water, and then slowly the water molecules mix around with the molecules of the salt or sugar or whatever it is, and then eventually all those particles become evenly distributed. This forms an evenly mixed solution. The dissolved particles are too small to see, but you can still taste them, and they still retain some of their original properties. That makes it a physical change. Can you undissolve something? Well, let's take a look. Yes, you can by a process called distillation. So if you look in the flask over here, if you have salt water, you can boil the water, and the water molecules will evaporate and go through here, and then the steam will cool and form pure water. But the salt is not able to evaporate, so the salt gets left behind in the original flask. Then after the steam condenses to form pure water, then you get the pure substance. These are all physical changes because the water was water all the way through, and then the salt that's left behind is still salt. Pure elements or compounds have unique properties, like their color, that you can use to separate them or to tell them apart. Color is maybe not the best way to tell, but some of these other ones are unique properties like solubility, how much of the material can dissolve in water, the density or how close together the molecules and atoms are packed together in that material. We can calculate that by mass divided by volume. The melting point is unique to each material, which is the temperature that it changes from a liquid to a solid. The boiling point is also unique, and that's the temperature that a substance changes from a liquid to a gas. For example, ethanol fully boils at about 79 degrees Celsius, so that could be a way that we could distinguish it from water, which fully boils at 100 degrees Celsius. Just by looking at them, they have the same color, but we can measure their boiling point and tell the difference between the two.